No. What is wrong with you? We have extra minute, guys. I do this, but I forgot to do it. Alright? I did this in fifth grade. I forgot to do this.
They're both negative, so you add them. They're the same as add.
Yeah, I'm sorry.
Hey, that's what I got. Didn't get the right answer. What I got. What I got. Yes, what I got. Work.
24 adds.
You're rectangle. I put an arrow like a triangle.
But they're both negative, you have to add them.
And then it becomes negative 7.
You
No, and then it becomes
But,
what's the number?
Negative 8 and negative 9 times it.
Then it becomes
that's a base.
negative 13. So did you get this?
That's a base.
Oh.
So you actually have to do the sum of the bases times you have the correct height. One base. You have to add the base.
34x plus 3, right? What? Equals 34x plus 3.
1/2. The sum of the bases. That is on the different sheets.
Yeah, that's the most fun.
Which verb?
Okay,
Oh my god.
so colored pens up. And first, let me start by saying that was by far the best warm-up I've had with any class the entire year. Hands down. Best work of any of my classes so far this year. Phenomenal. Fantastic. We'll talk more about that in a couple of minutes. So let's see how we did. And whether you got the questions right or wrong, I actually don't really care. I mean, it would be great if you got them right. But the process was really the focus here. Also, out of 4 questions, we've only done 1 in my class this year. So the 3 other ones, I was asking you to reach back into your memory banks from years past, or not only to reach back to the past, but actually reach back to the past and then somehow figure out something more advanced from it. That was not an easy task. So today's warm-up was not one of my normal warm-ups. There is a reason why, and you'll find out in a few minutes. All right, so let's get the answers and then we'll go from there. Number 1, what did you get? We'll start with Ezekiel, Isabella, Yadesh, and then Jed Lee. What'd you get?
I got 142.5.
Okay.
128.37.
Okay. Okay, I got 3 different answers.
129.37.
What did you say, Isabella?
Oh, that's what I think.
Wait,
128. So you have the same thing, Gloria?
128.30.
So you also agree it's 128.37? Correct answer is 110.7.
I was so close.
I was
But let's find out the rest. Find out the rest. We'll go back to that. So, number 2, what's the circumference? Start with Selena, and then back to Gloria, and then Gary.
10.45.
Okay.
10.156.
Okay.
I'm not sure because I accidentally did area, but I couldn't find the circumference, so I tried to
find the circumference, but I moved to the next one.
Okay, I'm sorry, I thought you had raised your hand. I apologize. It is 10.4562. Now, unfortunately, if you put 10.45, that would actually be incorrect because you can't just cut off numbers, you have to round it. So if you wanted to round, that's fine, but underline the digit, look next door, 5 or greater, add one more, it would have to be 10.46.
It's all like 33 only had 2 numbers.
That's fine. That's fine if you want to do that, but you can't just go like this. You can't just make numbers disappear. You actually have to round. Okay? Don't worry about it. You clearly know what you're doing, but you just have to work on the rounding idea, okay? You got a comment about this one, Valerie? That's acceptable because you rounded properly. You rounded to this place value, so you said, underline the digit, look next door, 5 or greater, add one more. So you added one more. Very good. Riata. That is also rounded properly, so that's fine as well. Okay? All right. Number 3. What did we get? All right, we'll start with Kianis, Michaela, and then Sebastian.
I got x equals 10.
Okay?
X equals 10.
Okay. Okay, Kianis, you feeling a little more confident now? Yeah, x is 10.5. Kianis was a little hesitant. She wasn't so sure of herself, but once she heard it repeated again, she felt a little better. Don't worry, Kianis, you're doing very well. What about this one? Find the area of that. We will start with Gloria, then Isabella, and then Jedley.
998.
Okay?
733.
I
Okay?
got 18.6 meters.
Okay, we got 3 different answers. Anyone want to jump in? Here, here, here. What'd you get?
I got 495.
Okay? Okay?
I got 500.
Okay? What'd you get?
495.
Okay?
515.
515? 750. The correct answer is
Oh, that was just 24 about that.
524.
Yeah, I knew that.
So, let's start. First of all, I started out by saying how impressed I was with this class, and I also have to offer you an apology. I keep forgetting that the publisher of this textbook did a horrible job with the last couple pages where you're supposed to have the reference sheet. And I think what they did was they published the book before Florida came out with their new reference sheet, and I keep forgetting that it's missing some formulas. So for the rest of the day, I am going to hand out an actual reference sheet so you can see everything you need to know. But all the formulas that you needed were supposed to be there. So we're going to start with number 4. And there was another aspect of this that was a little bit challenging, which was, this is called a complex figure. You were supposed to be introduced to this idea last year. When you're finding the area of complex figure, basically you break it down into its recognizable parts. And then find the separate areas and then put them together. This will actually lead us into today's lesson a little bit. So looking at this picture in number 4, what recognizable parts are there? Ezekiel, what do you see?
2 rectangles.
You see 2 rectangles, okay? So if I put a line right here, that might help some of the other students see what you're seeing. Is that what you saw? Okay. Just one problem. What's the problem with his interpretation?
There's a trapezoid.
Yeah, it's not a rectangle on top. This is actually a trapezoid. Because this is a right angle here, but this is not. It was a little bit hard to see. So I wish I had picked one that had more of a slant to it, maybe like that. But that is a trapezoid. So the rectangle down here was actually easy to figure out, but you had to figure out the trapezoid. To do that, you need to know the formula for a trapezoid, which is what the reference sheet is for. Here's the formula for a trapezoid. Area equals 1/2 the sum of the bases times the height. Here's the formula for a triangle. Formula for a triangle is area equals 1/2 base times height. So the formula for a trapezoid and the formula for a triangle are actually the same thing, except the trapezoid has 2 bases and a triangle has 1. Let me show you why. If I take this trapezoid and extend it all the way up, and I'm not sure how high I have to go, but if I extend this all the way up here, I'm not going to be able to connect it perfectly, but it will form a triangle. Eventually, these 2 lines will meet and form a triangle. So what we're really doing when we have a trapezoid is we're cutting the triangle off right here and adding a second base. So that second base has to be accounted for. So here's one of the bases of the trapezoid. The other base is this drawn line, but there's no number there. There's no information. What is it? Joelle? It's 20. How'd you get 20? Very good explanation. Look down here at the bottom. This is 35 from here to here. This is 15 from here to here, which means this must be 20 inches from here to here. So now we have almost all the information we need. We have the 2 bases. Now we need the height. The height is the distance from here to here. But the 20 is this whole distance. What will the distance be from here to here? What is that distance? 3 people see it? 4 people? Kivan?
10 inches.
It's 10. How'd you get to 10?
But you have to do 20 divided by 2.
Why divided by 2?
Because there's 2 halves.
2 halves? You think it's their exact halves?
No.
Michael, do you agree? What do you think it is? 11. How do you get 11? Ah, so it's 20 for the whole thing, but this piece right here is 9, which makes this piece 11. Now we have all the information we need to find the area of the trapezoid. The sum of the bases is 18 and 20, so that's 38. So we've got 1/2 times 38 times 11. Half of 38 is 19. 19 times 11 is 190, 209. Did I do that right? 19 times 10 is 190, and then add another 19, that's 209. So this would be 209. And Isabella, just because I know I had seen it on your paper, what was the area of this bottom rectangle?
315.
So this was 315 square inches, and then the trapezoid was 209. So we do 315 plus 209, and we get 524. Go ahead, Isabella.
I just wanted to say that I know what I did wrong.
Well-
I didn't divide it by 2.
Okay. It is a very common mistake with triangles and trapezoids. And so this is one thing that I want you to work hard on today, because we're going to use this more, is that when you're finding the area of a triangle or finding the area of a trapezoid, you always have to divide by 2 at the end or multiply by 1/2 at some point. You have to. It's not an option. It's the most common mistake. Think about it. You could be highly successful on the FCAT, not miss any of the geometry questions if you remember that detail, or you could be a person who forgets that detail and gets 5 or 6 questions wrong because you keep forgetting to divide by 2. So that's one detail, very critical, okay? Go ahead, Paige.
Is that 30.11 or 30 times 11?
Times 11. Sorry.
Wouldn't that be 418?
Then you have to add this.
Then divide by 2.
I get it.
Or so 5. 2.5 times 7.
Okay, now, excellent. Any follow-up questions on number 4 before I jump over to number 1? Now this is where I really enjoyed listening to my students. Number 1, I was thrilled. I couldn't believe the phenomenal conversations that were happening. And I loved hearing at least one of my students really trying to convince somebody else about what was happening here. And I loved the description that went on. Someone did a great job of convincing their classmate that this was a rectangle with a semicircle cut out of it. And I loved it. It was described as find the area of that circle, cut it in half, and then subtract it from the rectangle. And that was a brilliant description because when you hear it like that, it's so simple. But when you look at this shape, you're thinking to yourself, what do I do? I've had students in my classes go, okay, find the area. Okay, I'll do 5 times 5 times 7.5 times 9. I had students for number 4 multiply 20 times 35 times 9 times 15 times 18. That's fine. Because if you don't know what to do, and I insist that you do something, that's fine. I want you to do something. I don't want you to just sit there. But clearly, if you're just multiplying a bunch of numbers together, you don't understand what's happening. And area means you're measuring how many little squares can fit into this space. And so, if you think about it, that description was perfect. Because, let me use my highlighter to kind of illustrate what happened. Let me see if I can do this. So, if we pretend for a moment now, if we pretend the whole shape is filled in all the way across here, so the yellow highlighted area is this full rectangle, what would the area of that rectangle be? Or at least how would you find that? Now we're focused on the yellow highlight. Go ahead, Gloria.
19 times 7.5.
Now where'd you get the 19 from?
On the top, the space is missing on the bottom is 9, 35, 9, 5.
Okay, so this missing, and I love the way you describe that, that missing piece is 9. 5 plus 9 plus 5 is 19 for this whole distance times 7.5. So the whole rectangle, if we fill that in, the whole rectangle's area is 19 times 7.5, which is 142.5, and there was a bunch of people who had said that answer. But those people neglected this part, and here's the important part. Now we're subtracting that. And look what I'm actually doing. I'm literally erasing it. That's what's actually happening, is we now have to subtract that part. So you need to know the area of that. Okay? Gary?
I know the area of the circle.
Okay. So first of all, let me help my students see the circle if you can't. And I don't know how easy it's going to be for me to draw it. Let me try. So there's the circle. That's the circle. And it's not perfect, but that's basically the circle. And so what's the area of that circle? Go ahead, Gary.
It's 63.62.
63.62. So it's pi r squared. R is half of this. It's 4.5 squared. So we got to do 4.5 times 4.5 times pi, which we use 3.14 as an approximation, and we get 63 point, close to what he said. About 63 point, about 64, 63.6. But now, as one of your classmates had pointed out while trying to convince their classmates, is it's not really a full circle. Now we just are going to subtract half of it. So we need half of this. Divide by 2, and we get about 31.8. So now take the area of the whole thing and subtract 31.8, and you end up with approximately 110.7 or something close to it. Okay?
Because square doesn't mean it's area. And if it's completely bigger than its cube.
So, comments, questions, concerns on either of those?
Oh my
So here's the thing. I did this as a warm-up, and we took extra time because it really was actually more than a warm-up. I could have spent an entire day doing complex figures. You were supposed to have been introduced to it last year. Today, you're going to see three-dimensional complex figures. So you have to be able to go from two-dimensional to three-dimensional, and that's why I needed this introduction today. But I'll be honest, again, I said it was phenomenal. You guys did an unbelievable job. So we're going to come back to this. We're going to go ahead and grade our homework, and we're going to come back to these concepts in a little while. So as you saw in the introduction, which was the short video, talking about the idea of surface area. And it sounds like this grand idea, but surface area is just area. The reason the word surface is in there is because you don't just find the area of one thing, you're actually finding the area of all the surfaces of an object. Today we're going to talk about prisms and cylinders. So, talk about prisms, we're talking about shapes like this. This is a rectangular prism. We'll call this distance the base, this one the width, and this one the height. The surface area is going to be the area of all of the surfaces added together. Now, there's a formula that's on the reference sheet and in other places, and there's actually a bunch of different versions of it. Here's the formula. I do not want you to write this down, because we're not going to use a formula for most of what we do. We're going to use a formula for one thing that we do. Because we're much higher level, the formula actually makes things harder. Once you see what I'm going to show you, it will make much more sense to just think through it, okay? Also, we're going to look at cylinders. Now, the cylinders formula, and you are going to write it down, but you don't have to write it down yet. The cylinders formula is important because even though we can logic our way through it, we actually have to know this formula and we have to know this formula to make it work. And so in this case, it actually is very helpful to have the formula. But you're going to learn why the formula is what it is. This is actually a combination of formulas that you already know. In fact, you used both of them during the warm-up. So let me illustrate to you what we're really talking about today. So, if everyone will look here. This is a rectangular prism. So let me show you what I'm talking about. This is a three-dimensional shape. We can rotate around. Okay? So we're talking about surface area, which means I want the area of all of the surfaces. So watch what happens when I unfold the rectangular prism. What do we end up with? We end up with 6 different surfaces, which is called a net. We have 1, 2, 3, 4, 5, 6. We have 6 rectangles. So the surface area of a rectangular prism is really just the area of 6 surfaces. And it actually doesn't matter what size the different pieces are. It doesn't matter at all. Because it will still be 6 surfaces. The only difference will be the size of the rectangles that are making up the different surfaces. Okay? So that's a rectangular prism. A net is a very powerful way to look at what we're trying to figure out. Okay? Does anyone have any questions about the rectangular prism? Now, throughout today, you're going to be asked to sketch pictures or to use your mind to generate the pictures. I'm not going to make either of them, I'm not going to make drawing them required. I'm going to leave it up to you. Okay? But I truly believe that drawing it out is a huge step in the process of trying to figure out the solution. So now, Excuse me. What about a cylinder? So here's a cylinder, and it doesn't really matter the size of the cylinder. The cylinder is a circular top, a circular bottom, and then this part in the middle. Watch what happens when we unfold it. Watch it again, because this one is much more eye-opening than the other one. So when we talk about surface area of a cylinder, what shapes are we actually finding the area of? Paige? Yeah. We have the two orange circles and this rectangle. The area for a circle is pi r squared. Not only is it two circles, but the two circles are exactly the same. So once you find the area of this one, you'll know the area of that one. Now what about this rectangle? We have height, but we don't have this distance. Did anyone catch in the video what that distance is going to be? Selena, you caught what it was?
It said that the radius, like the radius from
Okay, yeah, you remember that part of the video. Good. That's not what it's called. The radius is this distance here. So that distance is definitely not the same as this. But you remember what happened in the video?
like they rolled it.
They rolled it. What were they trying to illustrate in the video when they rolled the circle to the left and the back to the right? What was the illustration there? Gary?
That the circumference is equal to the base of the rectangle.
That's exactly it. This distance right here is the circumference of the circle. A student in another class said, well, Mr. Gowd, that means that if this was a string and we cut the string and I stretched it out, it would go from here to here. And I said, yes, that's a great way to think of it. Okay? So the circumference is this distance. So let me show you the formula. Unfortunately, I didn't make this, so the formula is a little bit backwards, but let me explain. This is the blue, and this is the orange. This, 2 pi r, is the circumference of the circle, which is also this distance here. H is the height. So this is telling us the area of the blue. This here, pi r squared. Pi r squared is the area of a circle. Why is there a 2 in front of it? Pi r squared is the area of a circle. Why is there a 2 in front of it? Joelle? Yeah, there's 2 circles. You find the area of this one, and then you have the area of that one. It's the area times 2. So this formula looks really complicated, but it's really not at all. It actually makes perfect sense. 2 circle areas and the area of a rectangle will be the surface area of a cylinder. And so this is the type of material we're going to be working with today. Does anyone have any questions so far? Let me show you one last one, which was not as nice. I didn't make this either, but it's worth showing you. A triangular prism. I don't have the power to open it up, but here's the original, and here's the net. And so a triangular prism is a little bit different, but you can see that there's a triangle and another one. And the triangles are identical. And then there are 1, 2, 3 rectangles. So to find the surface area of a triangular prism, we're trying to find 5 different areas and we add them together. Okay? Any questions? Good, so let's go ahead and start putting this into practice. So, let's find the surface area of a rectangular prism. So far, what I've said is that we're going to use a formula for the cylinder, but for everything else, we don't need a formula, and I'm going to illustrate to you why as we work through this. So, watch what happens when I focus your attention on one side of this prism. So I'm going to actually just go over one of the sides with new lines. So now I want to focus on this side. What is the area of that one side? What's the area of just that one side? So we ignore everything else, just the area of that one side. Isabel. 120. How'd you get that?
I did 10 inches times 12.
Okay. So the 12 over here also applies over here. So 10 times 12 will give us the area of that. So far we have 120 square inches. Okay? But now I want you to watch. Watch what I do here. What did I just prove by doing that? What did I prove by moving it from there to there? What did I just prove? Gloria? It's the same thing. So how many of these rectangles are there? Michaela? There's 2 of them. So I already know one of them. All I have to do is take this one and multiply it times 2, and I will have the other one. So now I have, let me move this over here, so now I've got these 2 sides. Any questions so far? Yes?
Isn't that 4? I'll go 4.
Not done yet. Not done yet. So we've done these 2. So we've done this one, and we've done this one. Now let's focus on a different location. Now I want you to focus here. I'm going to do similar process. What's the area of the green rectangle? Should be mental math for most of us. Riante?
80.
Okay, how'd you get 80? Okay, but I'm looking at this green here.
Oh.
So the 8 is the bottom, but the 10 is over here. Go ahead.
It's 96.
It is 96. Very good. So the green one is 96 square inches. But again, watch what I do. If I take this and move it over here, there's another one. There's 2 of the same thing. So if there's 2 of them, I can take this 96 and multiply times 2. So there's 2 of these. Anyone have any questions? So now we've done this one and this one. Look what's happening over here. Reconstructing. There's one that we haven't done yet. We haven't done this top. So we've got here. And so what is the area of this purple? What's the area of the purple? Ezekiel? 80. Very good. So we get 80, but hopefully you are now seeing that there's 2 of those as well. So we multiply that result times 2. And now we have all 6 surfaces. 2, 2, and 2. That's 6 surfaces all together. And so when we add them all together, we will get the total surface area. Got a lot of mental math going on. You could also add them all together and then multiply times 2. Either way, you'll get the same result. Yadesh, you already got the whole thing? What is it? Yeah, it is 592 square inches. So there's no formula needed except for base times height. Once you got that, you understand what to do. Any comments, questions about how we found the surface area of this rectangular prism? Good. What about a triangular prism? So again, yes?
I know how to do triangles.
Okay, hold on one second. So again, there's no formula needed. You have to know how to find the area of a triangle and the area of a rectangle. Because as I showed you already, the net of one of these is 2 triangles and 3 rectangles. So it's a matter of focusing your attention. And so here we are again. I'm going to help focus your attention. Oh, excuse me. So we've got this triangle here to start with. And what is the area of that triangle? So, Garen, you said you knew how to do it. What's the formula for the area of a triangle?
The formula for the area of a triangle is half times base times height.
That's right. So for this triangle, we need half base times the height. Garen, you think you know how to do this specific one?
I don't remember how to find the height, I just know the formula.
Okay, good. So we need the base and we need the height. So there is something a little hard to see, and there's this little right angle right there. The height of a triangle is the right angle distance from the bottom to the top. This is a right triangle, so that is the height right here. This is the height right here, which makes this the base. Let me do it a different way. Watch this. Oops, excuse me. Let's take the triangle. This is a right angle right here. This is the base. That's the height. But look at what I did. I started here. This is the 4. This is the 5.2. So 5.2 is right here. Now I'm going to rotate this. 5.2 ends up right over here. So if we redraw it, 5.2 is right there, 4 is right there. So the area of this triangle is 1/2 the base, which is 4, times the height, which is 5.2. The other way to think of area of triangles is to do base times height divided by 2. You can divide by 2 at the end. Either way, it's up to you. So what is the area of this first triangle? You got it already, Selena? Okay, what'd you get, Isabella? 10.4, good. So we get 10.4 square millimeters just for this one triangle. But now I want you to watch. Let me see if I can put this back. So here's where we started, approximately. But look, there's another one back here. It's the exact same triangle. So if I have this area for one triangle, what should I do with it to get the other one? Chris? Just multiply it times 2. So there's another one, 10.4 times 2. All right, I'm sorry. Okay, so we do 10.4 times 2, and we get the 2 triangles. Now we need the 3 rectangles, and you just have to be able to focus your mind on the right information. So one of the rectangles goes from here to here, here to here, and there, and there. So that's one of them. So that's going to, I know it's a lot, guys. You're doing a good job. Just stick with me. It's just a long process, that's all. So it's 5.2 times 9. 5.2 times 9 gives us the area of that rectangle. Then we've got a rectangle on the other side, and that's different. We've got 9, but then it's times 4. So 4 times 9. And then we've got the bottom, which is this rectangle here. Here, that's the bottom. And that's 6.6 times 9. So we've got 2 times the 10.4. Then we've got to do 5.2 times 9. 4 times 9 is 36, and 6.6 times 9. So now we just got calculator issue. We just got to do all the calculator parts. This is 46.8. 6.6 times 9 is 59.4. Now we just got to add it all together. You already got it? Anyone else get it? Got a couple people who got it all? Okay, Kevon and then Isabel. Kevon, what'd you get?
163 millimeters squared.
Okay, what'd you get? Yeah, you get 163 square millimeters when you add it all together. So one thing I want you to understand is that I'm going a little bit slower because we're learning something. It'll go faster as you get used to it. Okay? Does anyone have any comments or questions on how we did this? Go ahead, Paige. Okay.
I don't get it.
This one or any of it?
No, I don't get that one.
Okay. Well, do you know where we got this first part from?
No.
The area of this triangle? And then there was another triangle in the back? So that first part is the 2 triangles. Then there are 3 rectangles. So it's about understanding what the net looks like. So let me draw out the net really fast. And it's going to be a sketch, but here's what the net will look like. It's going to be a rectangle, then another rectangle, and another rectangle over here. And then there will be a triangle on top, and a triangle on the bottom. That's the net of this. And so here is the two triangles. Here is this rectangle. Here is that rectangle. And here is the bottom rectangle. Find the 5 areas and we add them together. I multiplied the triangle times 2, so that counts as 2. And then there's 3, 4, 5 different surfaces. Okay? So there was quite a bit more for me to do, but I think it will actually be more valuable to give you an opportunity with my guidance and help to do the classwork. So we were going to do practice on cylinders, but the idea is the same, but for the cylinder you can use the formula, and did you guys get a chance to write it down? I told you you didn't have to worry about it yet, but I don't know if you got a chance to write it down.
Yes.
Okay. So let me put up the classwork and then I'll write it up here on the board. So classwork is going to be 4 questions. You're going to have 1 rectangular, 1 triangular, 1 cylinder, and then 1 composite. Number 15 is a composite. And the idea is to be able to handle the composite. Okay? So I'm actually putting 15 minutes. 15 minutes of independent and semi-group work time. So if you need to discuss things with your classmates, discuss. I'll be around to help as well. No, it says to draw the net.
I got you. I'll do it. Yes. 150, 150. Wait, you're not supposed to times 2. Oh, wait. No, you're just like that.
All right. So I do have to cut the time there. I would like to give you more time because number 15 is really important, but I'm going to have to cut the time there. We'll see how we did. So first, number 7 and 9. Number 7, I'll be honest, I expected everybody to get number 7 is 656. Number 9 was a little bit more challenging, but I tried to help you out a little bit, is 88 meters squared. Number 11, let me move this up. Number 11 is 408. However, if you got anything close to 408, I will accept it because the publisher at times uses a different number than 3.14. It uses 3.14159, and so it sometimes messes up the answers. So as long as you got something close to 408. Here's the answer for number 15, 384. What'd you get?
I didn't even get it right.
Okay, so
For 15? Did you send the phone to so she gets
Wait. Oh, I see. There's no 4 in that. I timed by 4.
Thank you.
No,
okay, so
I would have got it.
first of all, I didn't get a chance to do a cylinder example with you. So one thing I wanted to point out, this was really the biggest thing about doing an example, was that if you're given a diameter, well, that doesn't help because the formula uses a radius. So what do you have to do with the diameter to get the radius? Danae? Divide by 2. And so the radius of this circle is the distance here, and it's actually 5 inches. That's the piece of information you need, along with the height, to fill in the formula. As long as you fill in the pieces of information in the formula, then you should be fine. Number 15 was more challenging, and this is really the focus, what I really wanted to be able to get to. And so let's take a quick look at number 15. There's a lot of different surfaces. Did anyone count how many different surfaces there were that you had to find the area of? How many do you think there were, Ezekiel?
10.
Think there were 10? How many did you think there were?
9.
9. So we disagree. Joelle?
11.
Think there was 11? 9? 11. Gloria? 11. Isabella? 9. Yadesh? 9. Here's the thing. I know why you're saying 11, but there's actually 9. Because, everyone pay, this is the key. The surface that's inside here, we can't see that surface. It's covered. The bottom of the triangular prism is touching the top of the rectangular prism. You can't see that surface, so we don't include it. You could not take this top off, find the surface area of the bottom, and then add them together. You had to actually pay attention to what surfaces you can see. Surface area is the outside surfaces. It's not the surfaces on the inside. We can't see them. So this right in here, we couldn't see. So there are 9 surfaces. 1, 2, 3, 4 that we can see in the picture, but there are other ones. The triangle in the back is 5. The roof on the left is 6. The front has a back, that's 7. The right has a left, that's 8. And then there's a bottom, that's 9. There were 9 different surfaces you had to find the area of. Okay? More important is the thought process that you went through. If you had a good idea and you were working through it and you got close, then I'm happy. Okay? So you guys did an outstanding job. Here's your homework. Page 567, numbers 6 through 16 even, and then 24 to 29 all. And your next test is your quarterly exam,
Yeah.
which is next Thursday.